Good afternoon, scholars. Mr. Spears here. In today's lesson, we're learning how to perform simple molar conversions. In class, we've been learning about the mole and how it is a very important concept in chemistry. This picture illustrates how it is central to relating many different quantities in chemistry to one another. In other words, if you know the mass of material, you could, with enough information, use the mole to find the volume. Or if you know the volume of a gas, you could use the mole to possibly find out how many particles are in that sample. In order to perform molar conversions, you're going to need to know three molar relationships, and that is there's Avogadro's number of represented particles for every 1 mole. At STP, the volume of 1 mole of gas is equal to 22.4 liters of that gas. And then lastly, the molar mass in grams of any material is equal to 1 mole of that material. In our first example, we are going to find out how many moles is equal to 3.5 times 10 to the 23rd copper atoms. First thing that I would tell the student is get in the habit of identifying important information in these word problems. One of the things that has always helped me is to box what it is that you're trying to find and underline the pieces of information that are given to you. This way you can keep your information organized and always have a visual on what it is that you're trying to find or what the goal of the problem is. So to perform this conversion, we're going to use dimensional analysis, and we're going to start by drawing a picket fence. Remember to put your given in the upper left quadrant. Because we want to get rid of atoms so that we can have moles, we're going to put atoms of copper diagonal in the next fraction. I'm going to put the unit that I want up top in the numerator, and now I need to find values to go with these units so that the numerator is the same amount as the denominator. And so I remember that 1 mole is equal to 6.02 times 10 to the 23rd representative particles. And of course, an atom is a representative particle. Now, when you work with a picket fence, remember to always multiply by your numerators and divide by your denominators. Now, because entering scientific notation into a calculator can be a little tricky, I'm going to pull up this calculator and show you how to enter this into your calculator. So we're going to start off by multiplying 3.5 times 10 to the 23rd copper atoms by 1. Now, to enter a number that's written in scientific notation into a calculator, you're going to start by writing the coefficient, 3.5, and then there's a special button on the calculator. It's the EE feature. This represents the times 10 to the whatever, and on this TI-84 graphing calculator is the second option of the comma button. So if I hit second comma right above the 7, I get this small capital E. The next thing that I put is the exponent for the 10, and that would be the 23, and so 3.5 E23 is the same as 3.5 times 10 to the 23rd. I'm going to times that by the numerator, which is 1, and then I'm going to divide by Avogadro's number, so that's going to be 6.02, and then I'm going to put in the E, and then I'm going to put in the coefficient 23, and so 6.02 E23 is the same as 6.02 times 10 to the 23rd. I'm going to hit enter. Now when you write your answer, you want to make sure that you round it appropriately. Now for these molar conversion problems, the number of significant digits in our molar relationships are insignificant. We only have to concern ourselves with the number of significant digits in our given. And here 3.5 times 10 to the 23rd has 2 significant digits, so our answer needs to be rounded to 2 significant digits. So this gives me an answer of 0.58 moles of copper. In example 2, we're asked this question: what volume in liters will 0.6442 moles of argon gas occupy at a temperature of 0 degrees Celsius and a pressure of 1 atm? Well, first, we're asked to find volume in liters, and the information that we're given to find that is 0.6442 moles of argon. And then there's some other pieces of information that are crucial about argon. We're told it's at a temperature of 0 degrees Celsius and a pressure of 1 atm. The student should immediately recognize these as conditions of STP, or standard temperature and pressure. The fact that we're dealing with a gas at STP and we're asked to find a volume in liters should tell the student that we're going to be using in this problem 22.4 liters. So we're going to start by writing our picket fence. We'll put our given in the upper left quadrant, 0.6442 moles of argon. I'm going to write moles of argon diagonal in the next fraction. And then I'm going to put the units that I want up top, which is liters of argon. I need to find values so that the numerator is the same as the denominator. And of course, I remember that 1 mole of any gas at STP is equal to 22.4 liters of that gas. Again, I want to remember to multiply by my numerators and divide by my denominators. So when I take 0.64 0.6442 times 22.4 and divide it by 1, I get as my answer 14.38 liters of argon when rounded to the appropriate number of significant digits. In our final example, we're asked to convert 177.85 grams of iron 3 oxide to moles of iron 3 oxide. Here, we are asked to find moles, and we are given grams. Anytime you're given grams and moles, it's a very good indication that you're going to be using molar mass to solve the problem. So let's start by drawing our picket fence. We'll put our given in the upper left corner, 177.85 grams of iron 3 oxide. I'm going to put grams of iron 3 oxide diagonal in the denominator of the next fraction. And I'm going to put the units that I want up top, which is moles of iron 3 oxide. Now we know that grams is related to moles because the molar mass in grams of that substance is equal to 1 mole of that substance. And so I need to find the molar mass of iron 3 oxide. So we find out that the molar mass of iron 3 oxide is 159.7 grams per mole. Now this is literally the same as saying 159.7 grams is equal to 1 mole of iron 3 oxide. So here we have our relationship. So our numbers in our numerator are going to be that for every 1 mole of iron 3 oxide, it has a mass of 159.7 grams. Okay, I'm going to multiply by the numerators and divide by the denominators. So when I take 177.85 grams and I multiply it by 1 and divide by 159.7, I get for my answer 1.1137 moles of iron 3 oxide when rounded to the appropriate number of significant digits. Okay, that concludes today's lesson. If you have any questions, just send me a message on YouTube. For my students, write down any questions you may have to share in class. Good luck studying and have a great day.